So we've all been there, right? You're running a cable, you get past maybe 50 feet, and suddenly the signal just, falls off a cliff.
Oh, absolutely. You get those sparkles or dropouts or just
It-
nothing, a black screen.
It's just the physics of it. Standard copper cables, you just have too much resistance for that kind of thing.
They do. And when you try to push a high bandwidth signal that far, it just degrades. It turns into noise.
Which brings us to the hardware we're looking at today. It's the Avenview FO-DP4K-300-EMIX-S.
That's a mouthful.
It is, but it's a piece of kit designed to basically laugh at that 50-foot limit. This is just the sender unit, and it claims it can push a DisplayPort signal a full 300 meters.
300 meters. I mean, that's almost 1,000 feet. That is a massive run.
We're talking about covering an entire airport terminal, or maybe a stadium concourse.
Yeah, without a single repeater needed in the middle.
And the key thing here, it's not just about the distance, it's about the quality, the signal integrity.
Right. This isn't some compressed, muddy stream. It's maintaining full 4K resolution.
At 60 hertz.
At 60 hertz, which is completely non-negotiable for the pros this is aimed at. If you're running medical imaging or high-end digital signage, 30 hertz just looks broken.
You need that smoothness.
Yeah.
So to get that uncompressed 4K 60, they're using HBR2.
High bit rate too.
Yeah.
That gives you 5.4 gigabits per second per lane. That is a lot of pipe.
It makes sure you're not compressing the life out of the image or getting weird color artifacts just to save bandwidth.
And it does all this using a single OM3 fiber optic cable.
Right, and I noticed they went with the 850 nanometer VCSEL lasers.
Which is a really smart engineering trade-off. Using those on multi-mode OM3 fiber is kind of the sweet spot for cost-effectiveness at that 300-meter range.
So it avoids the super expensive optics you'd need for single-mode fiber.
Exactly, while still just crushing the distance limits of copper.
And I have to say, the connector choice is good too. It's SC terminated.
That is a huge plus for anyone doing field installation.
Uh-huh.
LC connectors are fine, but they can be so fiddly.
SC is just more robust. It clicks in.
When you're up on a ladder trying to plug this in behind a giant display, you want that confident snap. You don't want to be guessing.
And speaking of hiding it behind a display, the actual unit is tiny. What is it, like 3 inches by 2 inches?
Yeah, 3.2 by 2.1 inches. It's a box type design. It's meant to just disappear. You can zip tie it to a rack or stick it right on the back of a monitor. It's invisible infrastructure.
But it's doing some serious heavy lifting back there. Let's talk about the MST support.
Multi-stream transport. Oh, that is huge for things like video walls.
It lets you daisy chain monitors, right?
It does, or drive multiple separate displays, all from that one single fiber feed. If you're building a complex setup, you really don't want to run a separate fiber line for every single screen.
And crucially, it also handles DPCP compliance.
The handshake. I mean, there is nothing worse than running 300 meters of fiber just to have the screen go black because the content protection failed.
This makes sure the source and the display are actually talking to each other properly.
Yeah.
Okay, but getting this level of performance, the bandwidth, the MST, it can't be cheap.
It is definitely not. This sender unit alone is clocking in around $1,800.
$1,500, wow. And that's just the sender, not the receiver.
Just the sender. I mean, you have to look at the application here. This is not for your home gaming setup. This is commercial grade.
So you're basically paying for insurance.
That's a great way to put it. Yeah. If you're building out a smart building or a mission-critical control room, you cannot afford signal failure. You're paying that money to know that when you turn it on, it stays on.
It really does highlight that hidden backbone of modern AV. We all see the beautiful 4K screen, but we never think about the optical engineering it took to get the pixels there.
And that infrastructure is only going to get more complex. We're pushing 4K hard now, but as 8K starts to become the standard, the bandwidth requirements are going to explode.
It really makes you wonder if we're nearing the end of copper altogether.
I think we might be. We could get to a point where fiber optics just replace copper, even for short runs, like from your game console to your TV, simply because physics demands that much bandwidth.
A pretty fascinating shift to think about.
Yeah.
Thanks for taking this deep dive with us.